Well, here we are again. Do you remember these batteries from? Oh, hang on. Remember these batteries from the Acer Aspire, 18650 cells? I've been looking to buy new 18650 cells, and I came across from this is I don't know if they're Scandinavian, but at least Norwegian, Kjell Company or Kjell Company. It's an electronics gadget store, as you could call them, which sells a lot of different stuff, and they have these 18650 cells, and I'll show you the regular price for 18650 cells is upwards of, well, the cheaper ones are at around 100 per cell, and they go easily to 150, 200 a cell, so per battery, especially if you want 3000 or higher milliamps or milliamp hour. I'll show you the screen where I have the website and what I paid for them. So you can see a 4-pack for non-members is $349.90, so $350, which is just under $35 for 4. And the thing about them, if I mean, you can't, unless you're Norwegian, you can't read this, especially if you're English. But it says it's a notification that these batteries have an inbuilt or built-in protection against self-discharge and overcharge. And that makes these batteries just slightly larger than regular 18650 cells. And I'll show negative. If you can see, when I go back to the camera mode, and I have to, so I can see, you can see that they are about 4 or 5 millimeters larger. And I thought because I have these, now if you buy them as a non-member, you get them at $350 or $349.90, which comes to $87 or 87 kroner and kroners and 48 øre. Again, Norwegian letter, the Ø, which is like 1 øre, which is the smallest denomination we have, but we don't actually use it. The smallest coin we have is 1 krone, and 1 øre is 100th, of course, just as 1 cent is 100th of a dollar, and 1 øre equals a tenth of 1 American cent, or just below 1/10 of an American cent. But yeah, anyways, these are 18650 cells. They are 2600 milliamp hours, and I got them as a member. I think it was $299, which comes out to just under 75 kroners per cell. So that's a lot cheaper than. But I figured, even though they have this built-in protection, I'm guessing there's a sort of a battery protection or battery board, battery management under here, which is laid on top of. So what I figured I'd do is, please, you'll see the red flashing here, warning, warning, do not do this at home. But I'm going to do it right now, because I want to open it up and see if I can sort of extract just the 18650 cell. Because tomorrow, which will be Thursday, I will be receiving a battery spot welder, which I can't believe I got that at a price that I did. So yeah, it's already very easy to see that there's a regular 18650 cell underneath. And there is, I don't have fingernails, so I guess I have to use a pair of, these are circuit board pliers, which are a lot more friendly to use than yeah, there you can see there's I'm guessing it's spot welded to the and there is another plastic layer again. So there's a plastic here, and I will again carefully try. Now this is really heat shrunk on, of course, just like it should be. As you can see, the connections, everything are spot welded to the battery. There. Okay, so that's the protection off, and yeah, so that is the battery protection, or BMS. Now, before I take that off, now these have been, I bought them, it's been a little while ago, but they were fully charged. But let's find out what they are at now, before I take the battery board off. So they are 4.07, so just under. Usually they're like 4.1, 4.18, 4.2 when they're fully charged. So what I do, I just use a screwdriver. Actually, don't use this again, so I don't. Oh, wait. Got a bit of plastic under there. I mean, that's pretty far from what I would call a. I mean, it's a good connection, of course, but it's pretty far from what I would expect as what I would say a good quality, because as you can see, hang on, let me zoom in. If you can see there, I'm going to try and get it to focus. It's only got 2 spots, so they're just actually the one probe on it to spot weld it, and that is interesting. I would at least do 4. And the nickel-plated steel that they're using, I mean, normally what I've seen used in these situations is like at least 0.2. I know you can get it as low as 0.15 at least in millimeters, but personally I would at least go in 0.2. That's okay. Just for interesting, let's measure it, probe it again, and see what it is without the BMS board. I'm guessing it's exactly the same, but let's find out anyways. Yep, 4.07 with a 3. So, yeah. And now let's compare the 2 cells. Plus, minus, plus, minus. And now they are exactly the same size. There's. They are exactly the same. And I have 4 of these at 26. I mean, this is. I have absolutely no idea what the writing on these batteries means, but I don't know if you can see it, but it's a lot of letters, blah 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 blah, and it says P36 1L 267A5, and by the rating of the battery as a whole, which was around, I think it was just either just above or just shy of 40 watt hours. That equates to around about the same as these are, which is 2600 milliamp hours. And 2600 milliamp hours, these are 9.3, almost 9.4 watt hours per cell. And so yeah, I'm guessing it's like the original in these 26, which, because if it had been the first two letters, which is 36, had it been 3600 milliamp hours, that would be quite a lot higher in watt hours, but it's not. So I'm guessing it's 2600, and that works out just fine since I have these four. So I'm gonna be able to repair that battery tomorrow to get the laptop working just fine again. But can I, for fun, and I might even just whack it under the microscope if I turn the microscope on. Hang on. And let's see. It's a very, it doesn't really have a lot of components at all. There's 6 components. A cap, a resistor. Yeah, let's get it under the microscope here. Let's take a look at it. There's 2 resistors. That's a 470 ohm. R1 is a 470 ohm, and R2 is 202s on. That's a 2000 ohm, 2 kilo ohms, I'm guessing, and it's kind of hard. A G3MC. What are the other ones? I'm gonna have to turn it around but I thought, let's just, I mean, yeah, it's not really, you can't really do in-circuit test and get an accurate reading, but let's just do it anyways, just to see. So this is, yep, just under 2K, so that's fairly close to the in-circuit, and that should be around 400. Yeah, just under 4, just shy of 470. The caps are never, well, at least not as far as I know, are never written with a value on them. So, and I mean, my Fluke, I have an LCR meter, but so it comes out as, so it's 100 microfarad, and that corresponds with what I'd expect it to be. It's 100 microfarad, no, 100 nanofarad, or 100 0.1 microfarad, 100 nanofarad. So let's flip around and see what these chips say. It's, oh yeah, they're 2 of the same. 8810 BV3G2S, and the other one was G3MC. So that's interesting. That's all it really uses. That's all it really uses for a battery management board. So I'll be able to fix my battery tomorrow when I get the welder tomorrow morning. It's coming in the mail. I actually found a place in Norway where I could buy it, and it was cheap. I can just say it was very cheap, because I wouldn't have bought it if it wasn't. I don't want to spend. I would have built something, but at that price, I just couldn't. It was too cheap. Yeah, next video, I'll be replacing all 4 cells, because yeah, 1 cell was bad, but I always replace. If I replace 1 battery in something, better to just replace all 4. Take off the battery management board, because everything is connected by it doesn't matter. I mean, I get it in a where you use just the batteries. I get that. But in a laptop, the laptop and motherboards all have their own battery management system, which is just fine. So I will be doing that. Next video, laptop back together. See you then. Thanks for watching, guys.